Hey, here you go.
This chip is die.
If you guys need another one, that doesn't work. There's one here as well.
Oh, this one doesn't work?
No, I'm saying if it doesn't
Oh,
work.
okay.
This one.
Oh, you have.
Thank you.
Three of them.
Oh, you know.
Yeah.
What about this one?
Quality of this.
On the video.
But yeah, you can check. But I think it's okay. I don't know if switching off this light is possible.
We cannot see that light.
Yeah, that makes the motion.
Which is annoying. It's annoying.
What about
Or the blinds, yeah.
Yeah, that's the refresh of the.
yeah, no.
Yeah.
Yeah, it's far away.
Yeah, it's the refresh of this thing.
It will be okay. So we will do. More about, being able to see this light.
Does it matter where I stand, actually? Do you mind? Do people want to see my pretty face? Or... Yeah, I'm only short, you see. You've built it for a bigger man. Yeah. Oh, yeah. Oh, I'll do that. I'll do that. Yeah. Yeah. Yeah, we'll do that when I'm sat down.
What do you think? It's okay?
Matthew, do you want to
Look,
No, I'll do it.
Sure.
Yeah, I just want to check. Is that HDMI? Yeah, there is HDMI. I've got that.
Yes, but when we do,
I'll get set up then, actually.
Yeah, no. Yeah, if you
I assume it's actually okay.
check how many we've got as well. Just out of interest.
There's something that's traffic.
Evening all. How are we? Welcome again to DevOps Manchester. I'm going to have to keep jumping. Just a very quick agenda for tonight. So welcome and drinks, which we've already done. I'm going to just quickly go through some updates, and there's a bit of interactive stuff just to understand the type of people that we're getting to the meetups. Then we've got Matthew that's going to speak first, and then Chris and Caroline will speak second. I'll give a bit more information about their talk shortly. And there's a gap for pizza and drinks. So I'm sure it's important to everyone. Okay, so this is titled Market Research, and it's just to get a bit of an understanding of the type of people that are coming to the meetup. So it's just hands up exercise, there's no, you don't have to speak. Who is it the first time at DevOps Manchester? Thought workers are. Mark's counting, by the way. It's just we're going to publish this information on the website. Okay. So, in the audience, who feels they know or has an idea of what DevOps is? Yeah. Who is working in an organisation that they feel is embracing or working with DevOps? So that's a hesitant hand. A definite maybe. Yeah. Have we got half hand metrics? Yeah. Got it. So in terms of, if you were to put yourself in a box, which I know we don't like doing, but who would say their background is from a development side?
Is that if you ever did it?
Yeah. Yeah. So these are all, by the way, all the numbers, just out of interest, will be going on the DevOps Manchester website. Who now feels that they were in the box as a developer, but they're now cross-functional, so they're helping with operations?
All going down.
Who has a background in operations or sysadmin? It's pretty even. Sometimes you get more dev.
Yeah.
And can you guess what the next question is? Who now feels that they're actually cross-functional as a sysadmin or operations? That's good. Good stuff. Thank you. I think that's it. I think that's the yeah. So just for tonight, if you want to tweet and put things out there about the presentations, if you can just whack at DevOps Manc in there for any of your Twitterings. And again, as I always do, my pleading part, if anybody wants to sponsor or speak, that's our email address to get in touch. So tonight, we have Matthew, who is going to speak about DevOps tooling and how to choose the right tools for continuous delivery. Matthew was recently speaking at DevOps Breakfast. This is Matthew, by the way. An event by Rackspace, so it's going to be a very interesting talk. We also have Chris and Caroline from ThoughtWorks. Chris, yeah, over there. They're going to talk about, just bear with me, I've got it in here. Yeah, disk images as build artifacts. So using things like Packer, if anybody's heard of that tool. And there's even, I think, a tech demo in there, which is gutsy. So also just a big thank you to ThoughtWorks. Also again on Twitter, they like the TW UK North. If you can include that on Twitter, it's nodding. They've sponsored all the beer and the pizzas and the venue for us, and actually sorted it all out for me, which has been brilliant. So thank you to Amy and Carla, if she's still here. Without further ado, I'll pass you over to Matthew. Thank you. Oh, the only other thing to mention is that this one will actually streaming and it'll be available on YouTube. So we actually have a video of it. Dangerously looking professional.
This one. Can you see that at the back? Okay, good. Okay. What I want to talk about or share today is some observations and experience that touch on four things really. One is collaboration. There's some things about learning and sort of how we learn. What I call Singleton tools, which I'll explain later, but basically where there's only one instance of that thing in your sort of environment, and a little bit about Conway's law as well. My background's in software development. I've been doing that since about 1998. I've done some other stuff as well, cybernetics and neuroscience. So the viewpoint that I bring in may be a little bit different to what some people have. So I'm thinking about kind of psychology and interconnectedness of things and how that affects complexity and processing and things like that. I set up and run the London Continuous Delivery Meetup group, and also Pipeline Conference, which happened earlier this year. This is a bit of a plug for Pipeline Conference 2015, so if anyone is keen to do a talk about continuous delivery, then we will be putting out a request for talks in a few months' time. So look out for that one. That'll be sort of end of March in London. And actually, in the slightly longer term, maybe the back end of next year, if anyone's interested in doing like a north-based thing, I'm based in Leeds now. Leeds, Manchester, something like this. In terms of a tech conference that's focused on DevOps continuous delivery, then let me know, because I think that could be an interesting thing to get off the ground. There are enough meetup groups, and you can see how many people are today. Plenty going on. I think we should probably, break the London bubble and do our own more in the north here. So earlier this year, I started a small consultancy called Skelton Thatcher. My name is Matthew Skelton. The Thatcher is a friend of mine called Rob, and that's what we call it. And we're deliberately keeping it micro scale, in line with some of the recent kind of technology trends, microservices, and that kind of thing. And our focus is on helping organisations to adopt and sustain good practices for building systems that need to run at kind of web scale. I've talked to, so the stuff I'm showing today comes out of kind of experiences talking to and working with various clients over the last various organisations really over the last 3 years, depending on how you count it. But certainly the organisations that I've worked with this year include there's companies involved in tourism, one in betting and gambling, travel booking, financial data reporting, and healthcare. So it's kind of across the industry. They all have their internet presence as an important part of their business. And actually, a lot of these organisations, I realise there's some common themes that go across them all. And pretty much all of them have been online since about 1999, so just sort of at the dot-com bubble, either just before or just after. They end up being successful in their sector. So the name is typically either well known generally or is well known within that industry sector. Pretty much all of them ended up with a large core central database, which ends up being a blocker, or ends up being quite a significant, ends up hampering kind of continuous delivery and rapid deployment for various reasons. Certainly when I first went into many of these organizations, there are lots of different teams with different goals. That was another common pattern. Particularly if you look at the remit of, say, the database team versus you might call it IT operations, or the ops guys versus the developers versus the QA team. Lots of these kind of little groups, each with their own set of set of goals or set of understandings about what their role was and what they were there in the company for. So that's the context, and what I'll share today kind of comes out of these observations. So what I'm saying may well not apply to all organisations that build and run their own software, but I can imagine that that they do apply. They certainly apply to the ones that I've been working with, and I'm pretty sure they would apply to quite a large number of other organisations as well. Can you hear me at the back? Is that fine? Okay. So these organisations also had, they all realised they needed to adopt something like DevOps or continuous delivery or something like this. I mean, that's why I was brought in, or why I got involved. But they also had some underlying needs. They might not recognise them, but the underlying needs were to improve the team interactions somehow. It's very vague, but leave it at that for now. Also to look at ways in which the use of tools can improve collaboration. So opportunities for collaboration based on how we choose our tools. And this ends up being, I think, really, really important. If there's a single message to take home today, it's that the choice of tools can have a major positive or negative effect on the effectiveness of collaboration, and therefore your DevOps initiative. And tools can catalyze change as well. But what we don't want to do is to just have a big tick list, like the old style way of choosing technology tools. It does this function, it does this, it does this, it does this, great. I mean, I've been through that process with many, many times with lots of different kinds of technology, and it really only gets you so far, and it misses out on the human aspect of the way in which the tools are used. So basically, we don't want to just have these big tick lists of what the vendors claim their technology to do, and we want to look at some other things as well. So team interaction, the opportunity for collaboration, and seeing how tools can catalyze change and so on. Who has read more than half of the Continuous Delivery book by Jez Humble and David Farley? 4 people. Okay, great. Go and read more than half of it. Seriously, it's absolutely jam-packed with. I've never worked for ThoughtWorks, by the way, so I don't have any particular reason to push this book, but it's absolutely jam-packed with solid, sound advice based on practical experience of ways in which the vast majority of companies that build their own software should be doing it. So go and have a read. Yes, it was published in 2010. The vast majority of it is kind of trend independent. So there are some stuff which is arguably, which at the time it was written was quite new, and now seems kind of general knowledge. But the vast majority of it is still completely relevant. So buy a copy and digest it, because it's super valuable. One thing which is quite fun to do with a copy of the book, if you get the PDF version, print it out on A3 pages on a colour printer and put it on the wall like this, because as it happens, the subheading titles, you could put a tick or a cross against them, or you can score yourself out of 10. So it actually ends up being, and this is literally what I did at the place my last perm job. So you can see at the bottom here, well, maybe you can't. Anyway, release anti-patterns. My role there was build and deployment architect. So this is kind of my thing. And I scored us 3 out of 13. There were 13 different things, 13 different anti-patterns for releasing. And I reckon we were fairly good at 3 out of 13. The point of this is, if it's on the wall, just like with a card wall, you can have a conversation around it. So if you like, this is a kind of, you're using the book sort of as a tool, you're seeing the opportunity for collaboration. It so happens that the chapter titles or the subheading titles are easy to kind of work out whether you're doing that or not. So we ended up having some useful conversations just around the fact it was on the wall there. That's a bit of an aside, but you could get some benefit from that. So this is my definition of DevOps: highly effective daily collaboration between software developers and IT operations people to produce relevant working systems. I don't just mean software developers and IT operations, I mean everyone else. But the crucial aspect is that it's collaboration, that's working together. It doesn't just mean talking now and again on Skype, it means actually sitting down at the same monitor and using the same tools to do to achieve a shared goal. But for me, DevOps is not automation, not only automation. It's not just build and release, it's not just infrastructure development, it's certainly not just system administration. Whereas for a lot of people, it's sort of, for them, DevOps is close to one of these things here. For me, it's a much more, well, there we are. So it's a bit scary for some people. It encompasses quite a lot of things. Okay. Any questions at this point? Is that fine? Okay. I make 2 recommendations for tools in this talk. The first one is Git. If you're not using Git, then you need a really, really good reason why not. You might be still on Perforce, okay, fine, but you probably want to move to Git. Particularly as Perforce offer lots of other tooling as well, and just the source control bit, you can plug in Git and use all the rest of the Perforce tools. Same with TFS. Who's using TFS? Why? TFS, the server itself supports Git as a version control bit. You can still use the rest of the TFS stuff around.
Everyone keeps telling us not to use it. We don't have it.
Yeah, but you get so much more. Anyway, that's my first of only 2 tool recommendations. Is if you're not using Git, then use it. Unless you've got really, really good reason. But it enables so much. Not just Git itself, but we'll see in a bit. The kind of auxiliary tools, if you like, that sit around Git, enable some really, really good patterns. You don't need to see the details here. I'll just step back. If you're in a situation where you're trying to release, you need to release a new you need to release a configuration update. So a piece of software that's already in production, but you need to kind of tweak on config value. Maybe you're changing a feature toggle or something like this, or you're changing a timeout value. But let's say that you're the kind of IT support people, service desk, whoever you call them, the people who kind of are the gatekeepers to change in production. In many organizations, historically, these people have not been particularly very well trained. It's often the management in an organization sees kind of IT support or frontline service desk as a low skill activity. So that often, certainly in my experience, these people will certainly never have used Git and probably have never even understood version control itself. So if you present them with that and say, right, I've pushed a change into Git. Can you just have a quick look at it and then push it to the master branch or whatever and approve it to go live? That's what you want. But let's say you've got that approval step in there as a safety mechanism. If you present them with this, then they're going to laugh in your face because it's really not very friendly, is it? Unless you're already familiar with what this stuff means, even as someone who uses Git every day, it's very powerful, but quite clunky. Whereas if you kind of start to use something layered on top of Git, like a UI like this, then we've got some sort of commit log. We've now got some comments against a change, so against the pull request. So we can see the reasons why that config change went in. And we can also diff in the browser. And unless you're red green colorblind, then you'll be able to see red has been taken out, green has been, the stuff has been put in immediately. You're making Git much more accessible to the person who's got less experience. It's still the same technology, but the way in which you're using it, you're opening up for collaboration. So I did some work last year for a large online, this is trainline.com, this is where I worked before, my last perm job. We were working with some of what they called their non-core applications, which were applications which did not, which were not involved in the booking flow, so it didn't have a credit card associated with it. So they were seen as sort of, they were seen as valuable, but not not core to the main revenue-generating part of the website. That meant a few things. It meant that they'd been, on the one hand, on the positive side, there were kind of fewer, there was less process around how that stuff got deployed and built. But on the downside, there was less rigor about how they were built. So we ended up in a situation where the service team, the service desk team, like I mentioned, had very limited Git skills or version control skills at all. Deployments were manual, the servers were Snowflake, so all individual, we didn't know how to recreate them. There was no CI at all around the builds and no automated tests. And there was, for all these reasons, there was a perception that automation was risky, that there were problems, the potential problems with security if something went wrong, this kind of thing. So people were kind of nervous about changing it, even though they knew it needed to be changed. So what we did is we used ThoughtWorks Go, this is my second tool recommendation only for tonight, which will become clear in a minute. We used ThoughtWorks Go to build a walking skeleton or prototype of the deployment process from committing to the code repository and getting the code into production. This was kind of greenfield because there hadn't been anything like this before. It would all be manual copying zip files, that kind of thing. But what we wanted to do is to capture all of the steps that currently happened. So there was some manual testing. Oh, sorry, the developer deployed it to an environment themselves. Then the QA, the person who had the QA role, did some manual testing on it, and then kind of signed it off. And then finally there was the service desk person whose role it was to deploy into production. So we actually modeled that in here. And one of the nice things about ThoughtWorks Go is that you can model this stuff very easily with roles. So we set up 3 different roles: developer, QA, and let's call it production support. And so initially we had exactly the same sort of release process as before, except we were capturing it and displaying it in a tool. Some of these stages here, didn't actually necessarily do anything. It was simply the person with that role saying, yes, I've done a manual check, I approve it, and we can model it in here. And we opened up the firewall ports and things so that other people, the product owner and so on, could see it. So we got everything in here. And what we found was, because we'd managed to, because we talked to the people and understood their concerns and walked them through this and said, no, you still have the same kind of power, if you like, as before, except now you use this tool and now you click this button here. We got them on board fairly easily, certainly much more easily than without this, I'm sure. And by surfacing this information as well, we could have a conversation with security people saying, actually, if you want to know who approved the manual testing or who approved the deployment to production, just go to this UI, and you'll see the name of the person pulling from Active Directory who approved that deployment. So actually, it improved his visibility and security audit because we'd automated the stuff for him too. Because before he had no idea who'd done that deployment. So by using this tool in a way which was to kind of bring different people from different roles together and to get their trust in this new process, we actually found that it was we could get this working much more quickly than we thought we would, to be honest. So my second tool recommendation: if you need to build a visual representation of the deployment process, then you do a lot worse than going for thoughtless code, because there's so much power to model how the deployment stuff works, particularly with the role-based security and that kind of thing. It's so quick to set up. Now, a long pipeline like this is not really the way we should be deploying our apps, unless they're really small. We want to make our pipelines as short and as wide as possible, so we do as much stuff in parallel as we can. That's not the point I want you to take. So I don't want you to think we've got to have 1,000 different steps in our deployment pipeline. The point here is this was a bridge to moving to a different place where we can automate a lot of the deployment. Eventually, some of these steps in here that originally were manual, we just took out because people would say, oh, I don't want to click it, I trust it, it's fine, just send it through as automatic. But we had to go through the stage of getting people's trust first. So yeah, we built a walking pipeline with Skelton, we modeled the security roles. At first it had manual steps, but eventually the people who were clicking that button said, don't worry, you can remove that manual step. And we allowed everyone to see the UI, including the product owner. So that helped to get a lot of people on board. So basically everyone was happy with that, that's what we used the tool in a way which encouraged collaboration, which reduced fear of what was happening, fear of the change, and kind of opened it up for more people to see what's going on, rather than just using it as a kind of automation tool. Who's using Splunk or Logstash or something similar to Greylog? Okay.
Didn't Steve give a talk on it at school? You just see this big happy face.
So these tools are great. I think most people would probably think that Logstash and Splunk and these kind of things are for sort of production diagnostics and so on. But it's true, but I'd like to take a different angle, that there can also be a collaboration tool. So think of it like this: if you put Logstash on developer machines, so that it's easier for a developer to use Logstash to dig into the reason why their application's not working, rather than manually go and kind of grep the logs themselves, then you're in a position where the developers are using the same tools as the ops guys, the same kinds of things. And so when there is an incident, then you can pull a developer from the dev team, sit next to an ops person, and they're literally collaborating at the same computer using the same technology, and be able to write search queries and using queries in the same sort of way. So you're using the focus you use for Logstash, Splunk, whatever. Yes, it's for diagnostics and for transaction tracing and all the rest of it, but it's also as a way of encouraging collaboration. Obviously, that ends up being super useful in a real incident. So basically, people from different roles end up being completely familiar with what this interface is. Don't need to worry about the details. It's just there as a UI slide, but so they're completely familiar with that tool. It's not that, oh, those production guys have got this special tool. We'll come to this later. A special tool which I don't really know about. No, we use the same tool to understand what our application is doing at all stages of the life cycle, from on my development machine to in test to staging and production. It's the same tool. Why not? So I'm saying that we should value collaboration as a really key criterion of how we choose our tools. Which kind of might be at cross purposes, if you like, to the main purpose of the tool. So kind of we need to kind of take a step back and squint at the tool from a different way and think, how could I use this? How could I set things up so that we can encourage that kind of collaborative working? Make sense so far? Fine. This is Helvellyn in the Lake District, and it's about 800, someone might correct me, it's about 873 meters high, I think. That's actually Striding Edge. The summit is somewhere up here, a little bit higher. And that's the remains of a glacier in the pond there. Now, for a lot of people, climbing up that or walking up that hill would be probably quite challenging, unless you're a sort of outdoors person. It'd be probably quite challenging. It certainly looks pretty scary, and in winter, the conditions can be quite treacherous, and there's plenty of people who die on usually falling down the other side of there. But in the summertime, and if you like walking, then it's quite accessible. It's quite nice to get the view. This is a mountain in the Alps. It's close to the Swiss, France, Italian border, called Weisswies, and it's 4,017 meters tall. And that's me close to the summit. Now, there's no way I would have got there had I not been with one of the most experienced UK climbers, called Tom, and with somebody else as well. I just wouldn't have made it for various reasons. We were very lucky with the weather, but the equipment that he was able to lend me meant I could get to the top across the ice field. The point here is that the choice of tool can create a mountain of learning for different people in the organization. So somebody who's already very familiar with using Git and very familiar on the command line, or using another kind of tool, might say, oh, well, we should just go for this because it's really good, and it would allow us to do all of this stuff, allow us to reach, if you like, reach this height of technical excellence, or be able to do all these really cool things. But there'll be other people in the organization who are way down here in terms of skills and experience and comfort level. And what we don't want to do, unless we deliberately want to create extra silos in the organization, if you want to kind of bring people together, then we need to understand it's going to take some time and experience and the right conditions to get to the top of this kind of mountain. Never mind, well, that kind of mountain. Never mind this one in the Alps. We need to give time for people to become comfortable enough with sort of lower heights, if you like, so they get familiar with going up to that kind of height, get comfortable with what that feels like before trying to tackle something really extreme like that. So work out what the skill level is in the organization, and make sure you take people along with you so that they can actually ascend. But if you just point people to a 4,000 meter mountain and say climb that, they're going to stay at the bottom. So the way in which you choose the tools over time becomes important as well. Where are we? So we need to bring people with us. We need to appreciate the current skills and choose tools based on that, with the expectation that eventually we might get to the top here. Singleton tools, yes. So this is a prize bull. A farmer only has one of them. So they're very special, very expensive. And unfortunately, in many technology landscapes of many organizations, there's a prize bull. It's a piece of technology which is so expensive or special or worshipped that there can only be one of them, and it must be in production. We certainly can't let the developers have a license for that particular tool because that's either way too expensive or they wouldn't understand it, and we need to bow down and worship this special one. For me, that induces lots of bad behaviour, and I don't think that there are some edge cases where something like Oracle RAC is actually probably what you need. Arguably these days, not for anything online transaction processing, but probably offline data warehousing stuff. But generally, for most, I would have thought for most sort of web-enabled businesses these days, the idea that you need something super pricey, that you can only have one of those things, is lead to some sort of bad behaviour, if you like. It applies to log aggregation as well, so I won't mention any names, but there's definitely some log aggregation of search products which are eye-wateringly expensive, and there are alternatives which might not have all the features, but we actually, because you can put them in every environment, so when someone's looking at the test environment or the QA environment, they can use the same tools as being used in production or on their dev box. So you get familiarity across the board. If you've got only a special tool in production, then in fact you've got a tool silo between people who are not focused on production and people who are focused on production. So the way in which we choose our technologies and tools, so when I say tools here, it's also technology, so it could be database technology. And I'm arguing that we should favour, wherever possible, stuff which we can instantiate on multiple developer vagrant boxes and all the way down to different environments and in production. Because the value we get from that is almost certainly going to be higher than the theoretical maximum we can use with this special fancy tool that's only available in production. So we want lots of these, like nice smaller fluffy tools rather than big fat stuff. Yeah, we want to, rather than optimizing for this really amazing feature stack, let's optimize globally across all of our teams, across our organization, in terms of collaboration and using the same tooling. It breaks this feedback loop. If this prize bull special tool is only in production, then it becomes very hard to get information back from production, back up to development and QA and the rest of the guys. Because they don't have the same skill sets. No, you can't have any of that information from their tool because it's special, or we're not going to give you a login, or you have to put a ticket into the database DBA team to extract that information from the massive Oracle instance. Really? That doesn't feel like the way we should be doing this stuff. Far better to accept that we need to add a few more shards on the database and pay a bit more for that kind of side of things, but making sure we're getting feedback coming up to development. Who is familiar with Conway's law? Anyone want to hazard a definition?
Systems fit the organisation structure.
Systems fit the organisation structure.
Yeah.
Pretty much.
Yeah.
An observation by Conway in 1966, I think, that organisations that build things, software or products or whatever, are constrained to produce designs that mirror the communication patterns within the organisation. So if you have three teams, two of which that communicate really well, and then the third team which doesn't really communicate with the first two teams at all, then the software that you produce will probably have one bit where you might be able to draw a line between two sections because those are communicating very closely, and you probably have a third blob off to one side where perhaps the APIs are very well defined, and but it becomes awkward to change anything because the communication between those two parts of the system matches the fact that the teams aren't communicating very well. And there's a link to a talk I'll show you later because I'm definitely not doing Conway's law any justice right now. On 1968. So there we go. Organizations which design systems are constrained to produce designs which are copies of the communication structures of the organizations. It's called a law, but it's really more an observation of what actually happened. And this has been observed time and time again. The implication of this is that we can choose to either work against this. So let's just take this as a given. That we can't build, we're unable to build software systems that don't mirror the communication patterns within the organization. If we know that we want a particular kind of software structure, more and more companies are realizing that we need to change the team structure to get the software resulting like that, rather than the other way around. But the further implication of this is, if we know that we need to have a particular kind of team structure to get the software we want, but the tools don't kind of align with that, or we're trying to force the use of tools, say, if we've got lots of different vertical service teams like Amazon or Spotify or whoever, and we try and say, you must use this tool across all the teams, then that doesn't fit with the team structure and the way they want to use the software. Does that make sense? So that the choice of tooling needs to take into account the kind of law that we're working with. So if within our organization we have, so dev is in yellow and ops is in blue on this slide. If our organization kind of has two quite distinct groups of people, but who collaborate quite closely in the middle over specific things, infrastructure, automation, that kind of thing, then we might argue, well, for certain things, we should have shared tooling, like probably Git, version control, Chef or Puppet, let's say, for infrastructure automation. But actually, for server patching or for the lower level infrastructure piece, maybe if they're doing some VMware automation or something, the dev guys don't need to worry. We don't need to artificially find a tool which the dev guys could work with as well, because it's not within their remit. If actually we're operating a model of something more like Netflix, where we have full stack, properly cross-functional teams, then maybe every single tool needs to be appropriate for both kind of dev focus and ops focus people. But it depends on what kind of topology we've got for our teams and how closely we want them to work together, and that should influence the tools that we want to select. If we've hived off, if we've got an internal ops team, but actually they're providing infrastructure as a service, just much like Amazon or whatever, then they can have their own tools. They can have a completely separate set of tools from dev because there is no collaboration there. Fine. But it really depends on what we want from the organization, what kind of team interrelationships we actually want to appear, and then we need to take that into account when choosing the tools for the different teams. So if the teams if we want the teams to be separate and not collaborate, or not collaborate very much because they are providing internal infrastructure as a service, then let them have different tools, that's fine. Potentially, expecting people to use the same tools might actually take us away from the kind of system architecture that we actually want to produce. But if we want the teams to collaborate, then we need to find ways we need tools that will enable that collaboration. There's a really good talk by Alan Kelly on Conway's law and continuous delivery, and you'll find it on the London Continuous Delivery Vimeo channel at the bottom there. If you just kind of search for Alan Kelly and Conway's law, then you'll probably find it. So for me, when we're choosing tools for DevOps, then we should think about the collaboration aspects of the tools and really value those, potentially even before the other aspects of those tools. We need to avoid a mountain of learning and expect the tools to evolve over time, so we bring people with us. Tools that exist only in production, I think, are really anti-pattern, really bad idea for lots of different reasons, preventing learning, creating a silo, that kind of thing. When you think about the way in which our teams are set up, in the context of Conway's law, to produce the kind of overall system that we want, and then choose tools based on kind of tooling that fits the topologies and teams that we've got in place. And there's loads of other stuff that we want to put on there. There's 4 things which seem common to me from having a look at these different organisations. This is my advert. If you're interested in the operability side and a bit more about kind of choice of tools and so on, there's an ebook. If you search for HiOps operability ebook, then you'll get it, or it's on there. These slides will be online late today or tomorrow morning, by the way. And there's also a book called Build Quality In, which we've just published version 8 today. There are therefore 8 out of 20 contributors who've published. We're publishing by a lean pub, so it's kind of incremental, small chunks, small bits of value at a time with feedback kind of thing. And this is experience reports from people who are doing DevOps and continuous delivery, what they're doing. So you might find some interesting things in there. That's it. Any questions?
I've got 2 actually. The first one is the continuous delivery is sort of like something it's like you so big sort of you're about Netflix, see thousands of points a day. Developers committing code, it runs through a bunch of automated tests, it then gets deployed live. And I think, continuous delivery from a lot of the stuff I've read, it's kind of selling us that silver bullet to get away from these regular.
Continuous delivery is very different from continuous deployment.
Right.
Continuous delivery is having the option to deploy at any time. But continuous delivery is a pull system. So the product owner should say, I want this feature, and it should be pulled through the system on this side. Continuous deployment is push, so a Git commit will push that thing all the way to live. Two things that kind of look fairly similar, but actually are fundamentally different in terms of purpose.
Are you just in your experience of seeing companies do this stuff?
Yeah.
Are you seeing companies nearer to continuous deployment or continuous delivery? What is it, a mix? Or I suppose we're all.
Depends on where the value is.
Yeah.
I mean, if there's value, I think continuous deployment is a lot easier for companies that have basically a kind of single client base. So let's say like Facebook or Netflix, where you might have a large number of clients, and what they need is a high number of hits and people accessing it for statistical purposes. Otherwise, they can't understand what to innovate on next. Then pushing every commit potentially makes sense, but for other organisations, that there's less value in that. There's more value in having choice of when to deploy.
Yeah.
But it depends what's valuable.
The second question was, I've got some friends who are testers. Nice guy. Just in their part, their involvement, I mean, they're very much about, obviously they're in some respects against, but I've got other testers that are very much about writing automated tests, not just a code, but a business logic and where do you think they fit into either a continuous delivery or a continuous deployment pipeline, and where their involvement is, and how much they should, as a business, trust the automated testing, and where it's applicable to bring that manual intervention into the process?
If you've got an application that's sufficiently interesting, that has some, particularly if it's got user interaction, then you're always going to want some manual testing. Now that might not be before it goes live. You might do the manual testing in parallel. It depends on the risk profile. And that could just be a case of the tester speaking to the developer and saying, do you think we should push this live now based on the nature of the change that you've done? And they're collaborating on that. If those testers were a separate silo, then it's very difficult. But if they're actively part of the same product team, then it gets a lot easier. But they should be the ones who are. It's a different mindset, isn't it? As a developer, you're thinking about the domain model, you're thinking about kind of new stuff, and a certain way of thinking. The tester is that their role is precisely to kind of destroy what developers are, right? To really get in there with a fine price to part, and that's kind of a very different mindset. It's very difficult to play the same role at the same time. So it's still valuable to have that person who really understands dodgy parts of the application, who knows, how, oh, I'm just going to try this kind of load test, or I'll apply these parameters on there, and they're thinking of it because they've got a mental model, either explicit or implicit, about how that software is likely to break and what they should prod next. So I think it's still very important to have people thinking as a developer, and thinking as a tester, and thinking as an operations person, because those are three very different kind of ways of adding value to a system. But yeah, there's a huge amount of stuff, huge amount of tests which generally can be automated out. But those are the boring ones. Those are the boring tests. The interesting tests are the ones humans still have to do. So for testers who are used to kind of being GUI click monkeys and clicking through the same scripts, then that's not hugely valuable. For those people who really get to grips with what testing really is, it's not executing the same set of scripts day in, day out, or release in, release out. It's really getting to grips with understanding how the application really behaves, how it kind of hums, if you like. If it were a physical thing, like the pitch of the engine would change, and then that's going to go bang in 6 laps. So we need to do something now, or we need to adjust to something else. So it's that kind of approach where the tester can have massive value. The role changes somewhat. It's not running through a lot of manual steps, for sure.
Okay. Thank you.
Thank you.
Thank you for Tom for keeping Matthew alive whilst on the mountain. I think we've got pizza now, so we're just going to have a quick 15 minutes and then back into Chris and Caroline's talk. So I think there's pizza at the back, ready for everyone. Come on. You all set? You all ready? Has everybody had enough pizza and beer and what have you? Okay, well, I'm just going to pass you straight over to Chris and Caroline.
Hi. Hello, my name is Caroline. I've been working for ThoughtWorks since 2 years, and I'm a developer.
I'm Chris. I've been at ThoughtWorks about 6 years. My backgrounds are operations, dev, and QA. So, welcome to ThoughtWorks. And so we're both working on an internal project, and it's internal. They kind of let us experiment a bit and kind of try to drive out some new ideas, and this is one of them. So we had a number of problems that we see in typical deployments, and we think we've got a mitigation for some of those. So, but like all ThoughtWorks stuff, we kind of approach these like an open forum. So if you have comment, criticism in the middle of the thing, just let us know, and we'll be happy to talk, debate, that sort of stuff. So don't let us just go by easy. We're gonna try to demo some stuff here as well. Let's see if it works or not. But all right. If you're do that. Sorry. Of course, first thing. All right. And we've got a project here as well. If you want to try out this this whole pipeline demo thing, we've got detailed instructions on how to get it going on your own account. So. All right. So first, we're going to talk about some terminology here for people who haven't heard it yet.
So Phoenix Server, basically we do all our deploys on brand new boxes. Like there's no old configuration or old packages hanging around. It's just all like just out of the box.
Yeah, the idea is if you have a long-lived server, problems can accumulate over time, and we call it a snowflake server because it's beautiful and delicate, and you can destroy it easily. These sorts of things. Every commit we blow ours away. We create a new box. So that's one thing we'll talk about. And then there are some terms that I think get confused, provisioning and deployment. So in most organizations that I've worked with before, they're one thing. So deployment is this crazy fraught experience on Friday night where you draw the short straw and they say, hey, you're going to be here till 4 a.m. tomorrow. Doesn't it sound like fun? And we're gonna try to do all this stuff manually, maybe with some automation, and your Saturday is going to be spent with deep bags under your eyes as you try to fix all the problems that are one-off, right? So, and we're trying to say then we can split these ideas. Provisioning is the process of getting software onto a machine, and deployment is the process of pushing your latest changes to a live environment, right? And so we're gonna strictly split these. All right, and the tools we're using.
Some of the tools we're using. Who's here heard of Packer? Who here has used Packer? Okay.
So it's not Docker.
Yeah.
People are like, I've heard of Packer. Yeah, it's Docker.
So Packer is really awesome. Like you can tell it like what you want to provision with. So it could be Puppet, Ansible, Chef, any like that. And you could also tell it where to provision it to. So it could be DigitalOcean, Amazon, OpenStack, any of those.
vSphere, VirtualBox, and whatever.
Yeah.
You're kind of marrying provisioning of systems to cloud providers, and it generates an image.
Yeah.
And so for our demo, we're going to use DigitalOcean, and we're just some simple shell scripts, because we don't want to confuse people about what it's doing and what it's not. And we're also using Snap. So Snap is ThoughtWorks' new sort of continuous delivery tool. Go is excellent. We're using it in our project over here, but it's very advanced. So a lot of people find early on that it's difficult to get used to the concepts. So Go is kind of targeting the same market as Travis. It's sort of intro pipeline, free for small usages, sort of charging for additional build agents, that sort of thing. Very easy to configure. You can be up and running with one of these in about 5 minutes. So if you just want to experiment and try out a pipeline, it's just been released in the last couple months. I think it's pretty wonderful to work with.
Yeah, it's quite nice. You can link your GitHub account to it, and then you can select which project you want to import into Snap, and then you can just set it all up. 5 minutes.
Cool. So let's see. Okay. So common problem number 1, provisioning. Well, this isn't even a problem. This is in the case where everything goes right. if you're provisioning scripts, or say, God forbid, it's manual, if that has to be done against a live environment, how much downtime do you experience because of it? Okay. If anyone want to offer typical times deployment in your organization?
Last organisation I worked at, maybe you could get away with really quick deployment sometimes, but if there was a schema fix, 6 hours.
Okay. Fair enough.
You're asking the downtime or
So the time that you have to take nodes offline in order to get the new software on them before they're back serving the customer?
I'm talking notes, I'm talking service.
Okay. Yeah.
Okay.
Yeah. Okay. So
So yeah, using if you provision directly against a live machine, it depends on the complexity of your changes. If you use the image approach, it's completely decoupled from how complex it is. So typical deploy time would be 1 minute, 1 minute 10. Like this is what we usually get in our project.
yeah. So to be clear, what we're doing here, we have here several stages, right? You can ignore the first one here. The assemble image phase. What this does is it's spinning up an entirely new machine. So here I'm gonna trigger one of these just to have it going. Oh, there we go. All right. So that's going to spin up a new machine. I'll show you that in DigitalOcean while it's going. We'll wait till we get there. But so a new machine is going to spin up completely independent of your pre-prod environments, your production environment, any of that. And it's going to run all the provisioning scripts against it. So you can imagine Chef or Puppet or Ansible or something running along, pulling down Nginx or Apache or IIS or whatever it is, installing all that, all the underlying C libraries, anything you need to get that working. And then it's going to shut down that machine. It's going to take a snapshot of the disk, save that away, and then it's going to throw away the machine. So the end result of that, in our case, is these are our build images. Okay. So every time we make a commit, an entirely new machine is saved. Now that sounds horribly wasteful, but DigitalOcean doesn't charge you for this. So every one has the application name, the build pipeline number, and the git commit SHA on it. So you can say exactly what commit was the last commit that made onto that machine. Okay. Yeah. So then these are also completely independently deployable. So what Caroline's saying here is then if I say I want to boot a machine with that particular image, that takes 1 minute. There's no additional download, there's no install, there's no config, there's just boot. So whatever the boot time of that is.
DigitalOcean, by the way, to have one of those boxes up for a month is $5.
Yeah. It's £3.
I wonder how they make money. But.
Yeah. So so you can see here we have our old staging and 3 production instances, and then this Packer box is a Packer-540 or whatever. That's the new machine that's getting provisioned here. So and then if you want to see like how long an individual deploy takes, you can see there's like a series of rebuilds, right? Every time it goes through a deploy, you'll just see a rebuild, execution time 58 seconds, 59 seconds, 58 seconds, a random 2-minute 40. But that's the longest build or deploy I've ever seen. So, all right, basic idea. Does it make sense? Questions, comments, heckling? Okay. All right, so here we'll go over this guy. Yeah. Oh, man. Okay. All right.
So one of the problems you can be facing is halfway failure. So for instance, a couple of months ago, Ruby gems went down, and like our builds were failing. Now, if you happened to be provisioning against a live environment at that time, like you could like leave the machine in a really weird state, and it's also quite hard. It could be quite hard to recover from that. So this impact is just this risk is mitigated using the images approach, because we don't provision against live environments. Only when we're happy that all the provisioning went correctly, like then we deploy the image.
Yeah. So you can imagine, you have this dead machine that's called Packer blah, and it doesn't affect anything live, and then you say, screw it, I'll come back in half an hour when these systems are back up again, and you just click redo, and then it rebuilds again. Right? So, yeah, okay, so let's see. Manual modification is the next one. So, you have to make assumptions about your underlying environment if you have a long-lived environment, right? So you write a Chef script or a Puppet script, and you say, I want you to change this file from this location to this one. Well, if it's not there to begin with, your script's going to fail. And these sort of things happen. You know, you can imagine you had this sort of fraught night where all of a sudden there's a critical error and you SSH into that box and you're mucking with stuff, you're changing things, and you get things working, and then you're like, okay, all right, now I want to get back to where I was. Crap, you know, because you don't remember all the things you got to do to undo it. But if you're using an image, you can just click the redeploy button, and so this is where I can show you. Okay, so if I want to, I have to wait for this thing to finish assembling. But if I want to redeploy the last thing that was there, I can just go to any previous stage and just click the deploy button, and that will just it'll push that particular image onto that machine. So yeah, that's that one. We'll wait till that assemble finishes, and then we'll show those.
Yeah. Okay, so let's say you have a colleague who does mess up your box, or maybe a new feature doesn't work as expected. Like rolling back is really easy using this approach. It just takes 1 minute again. You just select an old image. So if you want this version, you just select that one, and it's up again in a minute.
So here, how about we show, first I'm going to go in, I've just created a very simple sort of example here. Let's say, here, we'll increase this a bit. We have just made this fake box root, so I apologize. Here we get our machine here. Let's see. Okay, so our script doesn't do a whole lot. All it does is install Steam Locomotive, so SL. Woohoo! And yeah, so say then I make a mistake, right? I do apt get move SL, and I accidentally kill the choo-choos. So now if I want to redeploy this, I can go back. So this one, this fixed script, this will do this. I can just say trigger. We can even see in our live environment. Refresh this. Yeah, so you can see this is triggering off again.
So for who thinks that choo-choo is cute, I have a colleague, every time you open a new tab in the terminal, the choo-choo would come. Waste 10 seconds of your day.
Let's see here. Okay, there we go. So you can see this is it's rebuilding now. It's basically just pointing it to the original image that it was at. Once this finishes executing, I should be able to just run that command again and be back to where we were. Okay. So, and this has happened to us in a few real situations. One time, we were coordinated with a third-party team that we were integrated with. We thought that they had gone live. It turned out they had. They found a bug and they had rolled back. And then we pushed live, and all of our integrations were broken. So we just clicked the last stage. And again, I think total time we were exposed was about 1.5 minutes before we realized. So this sort of thing just it takes a weight off your shoulders. A lot of times, if you want to be able to migrate backwards, you have to write a reverse script of your first script, and that's something you have to do on every single change that you make. And in this case, you don't have to worry about it. You just essentially can. It's almost like a commit where you just do a revert back to that point in time. Now, granted, this doesn't work. This isn't a database technique. This is more like your web nodes, this sort of thing. Those sort of volumes, like a database volume. Amazon has a method where you can actually remove that bit from your machine, do your upgrade, and then plug it back in after. But just I'd say leave databases outside the realm of this for now. Okay, so our machine is back. Same IP address and everything. I SSH back in, and I say SL. I get the choo-choo back. Okay, so very simple. There's not a whole lot there, not a whole lot of meat to it, but the idea is the same, right? Like I can go in. There's kind of two camps right now in ThoughtWorks on Phoenix servers. So the one camp last year, I was listening to a lot of talks on immutable servers, and it's a very cool idea. The idea is that you run your whole provisioning, and as the final step in the provision, you turn off SSH. So the idea is that that machine is never modifiable ever again after that last step. And you can, for audit purposes, you can guarantee you know exactly what is on that machine because it's not possible for a human being to go in and change it. But the problem is if you're logging, was it
still a terminal on it? So.
Maybe, but yeah, but if you haven't gotten your logging right, this is where it hurt us. We were like, oh crap, how do we get this thing? It's broken, you know. You can create with this approach. You can do one thing that's very cool. I can actually create my own additional production boxes, adding my SSH key to it. So I can recreate problem environments. So I'll show you that here real quick. So I'll say this is like Chris, oh crap, fixed it, something like that, and then say which size I want. I want a London box. My images, I can say which production image I had. Oh, it was this last one. I'm going to put our SSH keys onto it so we can both access. Go. And in 1 minute, I'll have a box that is identical to what's in our production environment. So for debugging, this can be very useful because you can try something in isolation and just hammer it and not worry about needing a specifically a production node. Yeah. But anyway, so our approach with the image thing was we said, we don't care if people access this as long as they can quickly undo everything that they've done there. So let them snowflake it in the short term. Let them add additional logging. Learn where we were missing our logging, and then be able to revert that quickly. So yeah, we'll see where the debate shakes out. But that's kind of our early thoughts. All right. All right. Horizontal scaling. Okay, so imagine you're Netflix, and you know that at noon today, the new Harry Potter movie is going to come out, and you're going to get slammed with 1 million requests, and you're like, oh god, we only have 10 servers. We're never going to be able to handle this. This is an instance where they have some mechanisms built around elastic scaling. So the idea is, as the requests sort of pour in, as you hit certain thresholds of load, you spin up additional instances. Now, if your provisioning and your deployment are one thing, that additional spin up could each, say take half hour to 6 hours or something. So you need to have ways to trigger things off very early. If you have something like this, though, where you know that you can spin up additional clones of your production environment reliably in 1 minute and entirely in parallel, that's very powerful. Imagine if you're trying to run Chef or Puppet scripts against 1,000 nodes in the same data center, and they're all trying to download the same binaries, right? Like that could be a huge amount of network bandwidth. They may actually even time out certain repos, and when they do that, say now you have 1,000, and then you have 50 nodes that are partially provisioned that have some issues. So with this approach, where everything's all been installed once perfectly, and I can guarantee that I've put that in an environment, I've pointed some tests at it, I can say it's what I want. I can have perfect copies of all of those across all of my instances. So so it makes that sort of elastic scaling a lot simpler there. Descent? No.
What happens if you want to make an incremental change to your image and like your OpenSSL change, or you've got 1,000 servers running? Is that issue of having to regenerate those 1,000 servers enough to counteract that?
Well, I mean, for each of those servers, the effort is just a reboot. So you could even do it in waves, but you're only installing the upgraded OpenSSL one time, right? Or OpenSSL. Yeah, so you provision on one box. It's just that image that results. You could then say you want to do a rolling reboot of all those machines against it. Now, for security, some other things we've been talking about internally is disk image hardening. So, if you want to have a secure image, you partition it in certain ways, and you set certain read-write permissions on those partitions, and then you limit the amount of sort of access to one narrow slice. And so we've talked about using a pipeline where the other team could, let's see, another team might have a pipeline that just applies security fixes, and then that acts as the base image for these ones to start. So in ours, we just say start with an Ubuntu 12.4 image and install these things on it. But we could say build it off of the ThoughtWorks secure image. and another team could have built that. So they could have something they're operating relatively independently. They push their change, and it could actually trigger a cascading set of rebuilds of images for every team in the company, and all of those on the next release would just include all those changes. So that's something we're looking at a bit.
Has someone looked about that? Someone spoken about that specifically in terms of security patching and machine imaging. That's actually super interesting.
Not yet. It's just something we just started talking about, but we haven't put it through yet. So I kind of want to see how it works in Anger. But yeah, if people are interested, we could put out the theory at least.
I mean, there'll be definitely a lot of people who've been interested to read, see a working example of that. It's hard for a lot of people to get their head around.
Yeah, that's fair enough then. Yeah, we can do that.
Mm.
Cool. Does that answer your questions? Is that okay? All right. Well, not a whole lot there. It's yeah, just some specific cases where I think this thing helps. Yeah. What are your thoughts? What are you?
Yeah.
What you just said about triggering on what people do. In this case, there was that that's true.
Okay. So in actually, Mark would be a good one to talk about this. You guys have he has a giant 3D sphere that renders of all the different builds triggering off each other, right?
Yeah, so we're going to go into some sort of pipelines triggering off the pipelines, or pipelines triggering artifacts and package repositories, or pipelines triggering off source code repositories. They could be internal or external. I'm guessing Snap's similar.
Yeah, so Snap, it's not quite as straightforward how it works there. Go, actually, I'll show you a little bit. They ours aren't tied up yet. We just moved to this central server, but.
So basically with Snap, it's not yet possible to do like the fanning in and fanning out of pipelines,
yeah,
etc.
Well, it does fan in now. That's a new feature that just. But
sorry.
anyway, once we get it wired up, these things it'll build up a whole graph of different services that all build off of each other. We're just centralizing a few of the sort of random services right now. In Snap, it has webhooks. So when we commit to Git actually makes a single GET call, just an HTTP request, to Snap and says, hey, I've got something new for you. And then Snap comes back and says, okay, let me pull the latest changes. You could do a similar thing. You can say, I want a webhook on the sales funnel that we're building to be triggered by a fix to like the staffing system or something. So then you can just have a final stage that says, do like a curl request to this other thing, and that would actually trigger off the next part of the cascade. But yeah, in Go it's more formalized, and you can get these big beautiful graphs of 24 different teams and how the requirements all funnel into each other. And Go is open sourced since like I think February or March, so have a play. Anything else?
Are you using Packer for anything that's got any persistence database built? Because obviously you can't smack a new image on a box if it's got stuff on there that can't be overwritten.
Right. No, that's our system right now that we're playing with is using third-party other APIs for sort of like persistence and whatnot. So we haven't experimented with it directly. I've talked to people who are working in Amazon though, and they said that there are called like elastic volumes or something. That would actually have the mount for the database.
Right.
So, and then you would detach that, and then that kind of is floating free, and then you could say, I want to update from Oracle 11 to 12, and then when I'm done, plug that back in. So they're doing some stuff like that, and they said that was a technique for getting Phoenix servers with a stateful node.
Yeah.
But I haven't personally done that yet.
And have you got any tools that you use with this for like orchestration? So, say for example, you bring up another database service to upload. How do you tell your nodes that exists?
Well, wait. Okay. I'm sorry. Separate. What you're saying? Are you saying how do you do load balancing and stuff?
No, well, so let's say you've got a database server.
Sure.
You add another database server, like this.
Uh-huh.
You need to tell those web nodes that exists and use that as a
Sure. So that sort of thing normally lives in something like a Chef or a Puppet or an Ansible, something like that. Those are configuration management tools. And so Chef in particular, I can say there's a Chef server, and you would register with it. You'd say, when you create these two boxes, register them as potential web nodes, or as these are the database nodes. And then you have a tool called Knife, and you can actually do queries where you say, I want to do a search of the logs on all of the database nodes. And it uses that internal registry to tell which ones they are and like hook you up appropriately.
But you still have to focus on web nodes.
Yeah. So this technique we deliberately narrowed the focus here. So if you download the code, you'll see it's just using a simple shell script to install SL. But normally at that under the provisioning section, you would plug in something like a Chef or a Puppet or an Ansible where you actually sort of tie it into other components on your network.
Yeah.
Yeah, Packer's responsibility is simply to generate a machine image from a definition given a cloud. But Chef and Ansible, all those, their responsibility is to install software and to wire up.
So if you want an extra database, then you need to know your client machines.
I wouldn't think so. I mean, it depends on how it works. If you're using something like a cloud-based or a Mongo, where you have like one, or even like a SQL cluster, usually you have one sort of front end where you connect, and then it delegates out through different shards and whatnot. So I assume as long as the DNS is pointing to that main entry point, then you could swap out other stuff on the back end. Do you think that wouldn't work, or?
One of the ones that's a fairly common pattern is the image has a read-only database behind it that syncs up, and you have a single write instance. As I've seen before, you have a single write instance.
Okay.
That then effectively replicates to read-only instances, which are used for review queries, and your machine image then includes effectively the read-only image on the back of the web server. You deploy those as one image. You do have to wait for the sync up.
Yeah, that's fair. Yeah, and I haven't, for our web instances, this has worked pretty well, but the database can push it on some different boundaries. And I can't speak to that yet. Any other thoughts? Okay, well then I guess we have the last couple bits for you guys. Bunch of information here. If you want to get to this Prezi later and the links and all that, got a link up at the top. The demo is complete, so it'll just require that if you want to play with it, sign up for a DigitalOcean account. It charges like 0.7 cents per hour, so 0.5 pence. So you can experiment for an hour and throw it away if you want. As far as if you're interested in ThoughtWorks at all, we're always hiring, always looking for people, especially in this sort of space.
So please speak to Amy. She's sitting there at the back.
Yeah. It's a good place to work. If you'd like to play with new toys and stuff, it's a good place. So, and then on September 25th, we're starting a new little conference called XConf. We're doing it in Hamburg and Manchester. So the Manchester one, Martin Fowler is going to give a keynote there. And hope to see you guys around. Should be some good talks.
Thank you.
So thanks again to Matthew, Chris, and Caroline for speaking. Thanks to ThoughtWorks, the pizza, and the beer, and the venue, and sorting everything out for me, basically. We're going down to Crowbar for a few drinks afterwards. If anybody fancies it, it's just down Piccadilly. So,
thanks, Pablo and Mircha, for recording.
And yes, thank you to Lisa for actually recording it for us. So, and thanks for everyone for coming. So thank you.